enjoyed it. I think now we want to move on to our next session, applying the maker mindset to achieve lifelong learning objectives and curricula. This session is being moderated by Doug Phillips, who is with Liquid Instruments. So we'll hand it over to you, Doug.
Great. I still enjoy my old picture, so that's
great.
No, this is very exciting. I think it dovetails on some of the comments made in the last panel session, which is really about lifelong learning. How do we accentuate all these skills that come in electrical and computer engineering or engineering at large? And how do we continue that journey from really the university all throughout your working life? And so this panel is really going to dovetail into those areas, and we have a great panel cross-section to really cover a broad array of opinions and experiences that should highlight some of these areas. And so first on your left, we have Bob Martin from Microchip. We have Katie Shea from UCSD. She's currently a junior. She also leads something called Project in a Box. We have Kevin Pham, who is currently the director of the Makerspace at Georgia Tech, also happens to be a Georgia Tech alum. And certainly you'll hear more about the Hive and how that impacts soon. And then of course, Shawn Heimel, who is, I guess, a professional maker, perhaps. And he has so many different things on his title that it's hard to cover, but certainly machine learning, instruction, and advising are just some of his areas. And so we're really excited to have them on board today to really cover both the student perspective, the university perspective, the pure maker perspective, and of course, Bob representing corporate. And so with that, maybe Bob, just do maybe a 2-minute introduction for yourself, your background, and we'll kind of move down the list so everybody can get synced up, and then we'll get going.
Okay, great, thanks. So I'm known as the Wizard of Make at Microchip, coming over from the Atmel acquisition. I know Shawn from a while back. I'm the person responsible for getting, at that time, Atmel into the Maker Fairs because of our presence in Arduino. So essentially, I'm the main technical liaison coming from Atmel into Microchip for the makerspace. So my point of focus is continuing that maker mindset that we helped start, that Atmel helped start with the Arduino system and keeping that ecosystem going.
Awesome. Maybe we'll go to Katie. Katie, would you like to introduce yourself?
Sure. Hello, everyone. My name is Katie. I'm a third year studying computer engineering at UCSD, and I'm currently the president for Project in a Box, which is a student org at UCSD that focuses on building different types of engineering projects. And I'm also a tutor for a hands-on course called ECE 5, which is Intro to ECE. So yeah.
Awesome. Thank you, Katie. Maybe Kevin, you want to give us a quick intro?
You're muted, Kevin.
Kevin's first time on Zoom. It's okay.
Everybody. Yeah. Hey, my name is Kevin Pham. I'm the Interdisciplinary Design Commons Makerspace Director at Georgia Tech. Prior before my role, I've had 8 years in the labs and helping develop curriculum. It's a pleasure to meet everybody.
Awesome. And then Shawn.
Yeah, I'm really excited to be on this panel. I got my start really at SparkFun, where I was initially an engineer designing some of the boards, creating some Arduino libraries to help people get started with those. And I eventually moved over to the marketing side where I started doing videos and also making projects more or less professionally as a creative technologist is what we called it. But essentially that professional maker where we made projects, we teach the technology, show them off just to get eyeballs on the site, inspire people, teach people, and everything that goes along with doing maker type projects. Once I left SparkFun, I started doing more freelance video, and I've been working primarily with DigiKey for the last 2 or 3 years, where I dive into some of the technology, and it's a little less maker, although I still do some projects for fun and make videos about them. It's more about finding ways to inspire people and teach people the underlying technology. And I focus on a lot of the embedded stuff like microcontrollers. I did a series on RTOS, and my recent projects have been on learning FPGAs because I haven't touched those in 15 years. So it's relearning, finding cool ways to interact with it, teaching it, and making it fun from a, either a maker perspective or continuing education.
Great. Well, Shawn, thank you. And for the broader group, I'd like to draw your attention. I think Bob and Shawn will get high marks for their background, which is not fake. That's their real office with real maker activity. And so, yeah, there you go. So as we're discussing the next series of questions and topics, obviously we're coming from a panel that has very deep experience on lifelong learning by the backgrounds nonetheless. And so maybe, Bob, I'm going to throw this to you to start us off. The way I see it is lifelong learning can be, there's lots of obstacles for it, whether you're a student, mid-career, late career. And it seems to me that in the last 10 or 15 years, that really the access to technology, whether it's by cost or by support in the community supporting as a whole, has made it so that really anybody who really wants to learn something or wants to take that step out of their comfort zone can do so without a lot of risk and without a lot of financial burden. Do you believe that's true?
Yeah, no, absolutely. The cost of entry now into making, I think I'm going to focus on the eval board and the technology part. Eval boards now are $5. And so your cost of entry is $5 and a USB cable. So essentially a venti latte and a USB cable is what's going to get you going in the technology part. And then, but the interesting thing is the focus on all the eval boards, and I wish I could swing my camera around without giving everybody motion sickness, because over here, down over there where that scope is, I must have at least 40 eval boards sitting there. And the other part of the equation that I find interesting, though, is even in the Bay Area right now, the surplus stores have gone away, which is unfortunate. It was just kind of a byproduct of COVID. But even that, there's still that surplus store thing where, technology becomes outdated so fast that even stuff that's 5 years old can now be picked up for 20%. And then on the other side of the equation, the hardware stores now, I'm a weirdo that used to wander through hardware stores just randomly to looking for stuff. So
you're a Radio Shack person?
I was a Radio Shack person. Absolutely. Built my first pair of speakers from Radio Shack parts.
Nice.
So, yeah.
Awesome. Well, Kevin, maybe I'll kick it over to you. Similar question, but coming from the lens of students engaging with the Hive and with your makerspace, do you believe that that's true, that the students are certainly able to come in and utilize that center, and maybe you provide it and maybe you don't, but really even the center itself can deploy really anything for student consumption? Is that true? Is that what's happening in your institution?
Yeah, I mean, if you look not just in my institution, but nationwide, look at all these maker spaces that are popping up. It's there is a huge support for these things, and these spaces. Bob's covered a technology portion. There's the cost aspect, but when we approach and build these communities, these maker spaces are more than just building and creating skills, right? They're also building communities, leadership, and the confidence for the students to really go to take that into their personal lives moving forward. So yeah, I think the barrier of entry to do these things have definitely been lowered. Yeah, I mean, right now we have 140 volunteers and around 300 students visiting currently, and that shows the commitment and the embracing of the culture the students have created here. So yeah, definitely, I think the barrier of entry has been lowered.
So Shawn, given your line of work, obviously you want to connect to your audience, and connecting with your audience requires that you're utilizing things that they can kind of mentally connect with, either technically or cost-wise. Do you find that you're able to translate what you're doing better because of that barrier of entry has been lowered?
Sure. And I don't just look at it from a hardware perspective, although, $5 dev boards are fantastic because they used to be $100 back when I first started, was a professional engineer. Not actually P.E, but, getting hired as an engineer, they were hundreds of dollars for dev boards. They were ridiculous. That has helped, but I also think the access to content and things like the internet bringing us together where we can create communities that don't have to be local has been massively beneficial, both with things like SparkFun, Atmel at the time, and now Microchip, but Adafruit. These kinds of places can offer communities for people to join, forums for people to chat about common interests like technology. And from my perspective, the ability to distribute content is huge. I can go to YouTube and learn essentially for free almost any technology I want. And this is starting to, I believe, supplement, if not replace textbooks, although a lot of times the YouTube content, the things that I teach focus more on the hands-on. I try to supplement textbooks. I see what I do as lowering that barrier to entry because maybe I go to college and I learned the theory behind digital logic design or machine learning, which is great. But then at least when I went to college, and this was 15, 20 years ago, it wasn't a really hands-on. We'd learn a bunch of theory and then we'd have a project at the end of the course that went, oh, just apply it. And here's a Xilinx dev board and it's $100. You have to give it back when you're done. Here's the 2 GB install, have fun with the tools. And it was rough. That barrier to entry was huge. With a combination of open source tools, people focusing on making things easier, like Arduino, even if you don't consider it a professional tool, it lowers that barrier to entry so people can go, oh, I'm learning embedded C. I have this super easy way to apply it. And like the FPGA that I've been playing with is a little ice stick, and there's 2 commands I type into a console and it's burned onto the FPGA and it works. I don't have to do this crazy install now. So I think things like that outside of just the hardware are now making things easier. So for me, I try to create content that supplements what the textbook and theory is being taught or can be learned. And then you go watch my videos, you learn how to do it. And the hardware and software stacks now make it so easy just to try out your design and get hands-on with it. I think that's huge in the last few years.
Awesome. Well, Katie, your perspective is near and dear to a lot of people on this call because you're currently a 3rd-year student. And so you are right in the throes of completing your education at UCSD. What is your take on how technology, at least in your time frame at UCSD as an example, has really lowered the barrier to really make your project in a box a reality?
Yeah, I think going off of what Shawn said about like open source and like all the online resources, I think those have been super helpful to me personally when I like want to work on projects or like explore different things. I think it makes it a lot easier to see what other people have done first before me and then like building on top of what others have done. So it really helps to have like a starting point that's not just like you can work off of what other people have done before you, which is much easier than just trying to start something from scratch sometimes, especially if you're just, if I'm trying to work on something for the first time. So I guess an example would be when I was working on a circuit Python, which is like another board that uses Python to program the microcontroller instead of Arduino C. And there's just a lot of resources online to help get started. Like I never even used this board before, but I was able to see what other people have done and kind of build off of that.
Awesome. So dovetailing from there, it seems like as the cost and the access to both content, hardware, software is now really to a point where anybody who wants to have it can. But unfortunately, there's this thing called COVID that kind of came in and threw a wrench into a lot of areas of both education and work. And so, Katie, for you, just to kick us off on the next question really is, how did you adapt from allowing yourself to continue to learn outside of traditional classroom during COVID? And how did you overcome that sense of collaboration that I know a lot of ECE students like to have, as we're a make community, so to speak. How did you do that? And can you talk to us a little bit about your journey coming through there, and how you adapted?
Yeah, so during COVID, it's definitely a lot more difficult to, I guess, connect with other students, especially virtually. But I think I've gotten really used to Zoom meetings and just collaborating that way. I think the nice thing about Zoom is that you can like collaborate anytime, anywhere, basically. And screen sharing has also been super helpful. In terms of, I guess, like hands-on activities, I've noticed some of the classes at UCSD for the hands-on ECE courses, we would send project kits out to the students, so they would still get to have that sort of hands-on experience from home. So it's kind of like bringing some of the lab materials home, which has been really cool, so that they don't just have to like watch simulations or something. They can still have time, the opportunity to work on hands-on projects too. Yeah, and one of my classes, I took one of a hands-on project course, and they sent me like some of the hardware components, and I also got a chance to like request some parts to be laser cut and sent to me, which is really nice. So there's still opportunities to be flexible around hands-on learning from home.
Great. Kevin, I'm just going to cycle back kind of to you, with the makerspace, obviously, in similar fashion, right? You have a lot of restrictions. There's not a lot of engagement for a while, but you must have tried to keep the doors open and people engaged in a lot of different ways through that period. And so can you talk to us a little bit about some of those experiences and how yourself or how your constituents were able to keep that learning going? And I think the hands-on component is still obviously at the core of ECE, and maybe describe, how students were able to continue that at home and how that worked.
Sure. So, I mean, COVID did cause quite a bit of complications, but if anything, it showed how resilient our students are. I mean, they were able to adopt a hybrid learning. How innovative some of our staff members were. They will send some of these kits home. We had the option to close our facility down due to COVID, and like any other space, I talked to our students and I asked, what kind of commitment we want to make to our community, because maker spaces are about community and that hands-on learning. A lot of students depend on that. So our students actually decided to open up, once with a semester break between. Of course, we upped our cleaning protocol, but it's just so amazing to see, like, how we dealt with the issue. Even though we had reduced on-campus presence, a lot of students were hybrid or remote learning. We actually had, our machines are running pretty much the same amount of time. And it shows that given an opportunity, students will take advantage of it. And that actually brought me a lot of joy. And, seeing the community come together despite, difficulties, and actually trying to keep these doors open. And I have to say, I'm proud of our students. We kept the doors open in fall and spring, and moving forward, we hope to keep it open. So it was a great opportunity for us to really learn about ourselves and figure out better solutions, because we're engineers, right? We can figure out solutions how to keep these things open.
So Bob, going to you, obviously, given, everybody in corporate also needs to keep learning. And so what were some experiences during COVID? Obviously, if I look behind your picture there's not a whole lot missing that you can't pick up and run with, but
yeah,
your observations about, the corporate experience and how people were able to continue learning, continue the maker ideology, even though, we have to juggle a lot more at home, from the dog to, time to everything else. What were some experiences that kept either you or your team members going at Microchip?
Yes. So there was two instances, because just after this panel, about an hour after this panel, I'm meeting with one of my ASU capstone teams. And that was, again, we've heard the term kit mentioned several times. And as you've pointed out, I have a vast amount of material where now I have to spend more time, and I don't mind doing it because it's worth doing it, and making sure those, putting together kits, because I'm just not sending them in evaluation board. I'm sending them the wires. I'm doing a lot of soldering, and to make sure that, these students that are, spread out all over North America. And now I have actually a student in Canada, up in Toronto, part of the capstone team. So I've got some custom things going on there. That has been, a bit of a challenge, but I did it last year and we're doing it this year. Corporate wise, it's much the same thing. Is I've adapted to, I won't say lowering expectations, but making sure that if I'm sending stuff to, my partners such as Adafruit and SparkFun, and Arduino, that those kits or those not so much those prototypes are well taken care of. So and then the biggest challenge I have right now is I'm also mentoring at an underprivileged high school in South San Jose. That's a bit more of a challenge, because that I have to also adapt that this is even have some more physical mechanical parts, and I've actually re-engineered some stuff because these kids don't have access to a lot of power tools. There is a robot shop, but I have to de-scope some tasks and things, but we're getting there.
Yeah. So do you think, Bob, just to follow up on that, do you think that, and this is coming through on chat a little bit, do you think that over a certain amount of time, because of those issues, we've reduced the complexity, or we've simplified what we can do to kind of a programming function that's low cost, easy to do, maybe a couple of wires, maybe an LED, and we've reduced it down to these very basic, functions of microcontrollers versus, the broader concept of either, tinkering with circuits or robotics or things that are a little more involved and have a higher investment level. Do you feel like we've almost regressed because of COVID to this, $5 board with a circuit and just kind of program it and call it Maker?
Yeah, because again, you want to lower the risk of physical damage now. Because if I'm teaching a soldering class or I'm hands-on in a lab with a bunch of students, instinctively I can go, okay, make sure, that these power wires go like this, and I can show them a picture of the board, right? So again, students are scared to blow something up, in air quotes, let the magic smoke out of the board. So yeah, I have to tamp that back, because that intuitive sense sometimes isn't there, which is fine, and it's tribal knowledge that I have to pass on.
So Shawn, do you feel like you have changed the complexity to which you talk to your constituents, or do you feel like you're in the same zone, or how are people reacting based on the availability or the complexity of doing it like literally on their own versus, having some mentorship? Do you feel like your material and your messaging has changed in the last 18 months?
Not really, honestly. My messaging, or the content that I create, especially videos, I usually try to focus on the fact that I'm going to be talking to one person who's going to be individually watching my particular video. And I that's not the same as a classroom environment or a workshop or a makerspace. It's just a different presentation. So my stuff in particular hasn't changed. I kind of assume that either somebody can afford the things that I'm teaching, in the sense of like, oh, it's a $20 dev board. I try to keep stuff under $100 that the average person could impulse buy. And I know that's still struggling. That's still a struggle for, some schools to be able to afford that per student, but most of my audiences generally already graduate, can spend a little money, but I try to keep things as inexpensive as possible, short of like buying raw components and making your own. But yeah, I mean, things like one of my absolute favorite devices is this Analog Discovery 2. This thing is an oscilloscope, function generator, logic analyzer. It does 90% of the things I need to do, short of being able to, sense 20 megahertz signals and above. Like if I go into like RF range, like, okay, it's going to struggle, but basic checking gates, checking outputs of stuff. This is my home bench basically. And I've got a Keysight scope, and that only gets used when I need to sense higher stuff. But, there are tools that we can buy or use, I think, for the home bench that replaces a lot of the things that we were using in the labs. Up to a point, right? It's not a network analyzer. I can't do RF with it. So for some basic learning, we have tools available to do home labs easily these days. Also virtual, like there's Arduino simulators out there that really for beginners. I do an Arduino course on Udemy, and I encourage people to use this simulator, and it saves them $200, and they love it. It's very basic, but they can learn with it.
And I just want to make a quick comment. I know there's some concerns about the oversimplification of learning and, using these cheaper dev boards. To comment off what Shawn said, we do have network analyzers. We have all these expensive equipment, but my messaging or my goal is to really inspire people through confidence. It's a building block, right? I want because we're all engineers. It doesn't matter if you're electrical, mechanical, or even industrial design. We want to basically give students the building blocks and the confidence to actually continue learning. And I used to work in a more formal lab setting, and we still have those. But I think it's very important for us to offer these more simplified experiments, so to really light a fire within their, engineering soul, right? And I would hope, I remember we had a bunch of donors come by, and the donors looked at our laser cutters, and they're like, oh, look at all these things the students are making. They don't look very complex. Some of them are pictures. I'm like, yeah, but they're still learning a skill. And I think through that, they actually learning their skills, and they will apply it later. And that's kind of, our goal. It's really cool to see these students grow into these confident engineers. It's great.
Yeah, real quick, because that's a great point, Kevin. And I structure all of my content when I'm teaching. I focus on giving building blocks, even if some of it's assumed, like, oh, we have to black box this for now. I focus on giving them the building blocks. And if I can't get something to blink in like 15 minutes, I have to assume that they're going to lose confidence in their ability to do it. So that's how I try to capture people into it. And then you give them the building blocks and you build up to more complex stuff. That's absolutely perfect.
Yeah,
so
that's
oh, go ahead.
Yeah, sorry, real quick. Yes, Shawn hit the nail on the head. We corporate wise for eval kits, there's a thing called UBI, out of the box experience. And blinking a LED, connecting to the cloud or whatever, about 5 minutes, couple clicks. If that doesn't happen, we've lost our ability to make an effective eval board.
Yeah, and I think that's probably that's the $1 million tension point, that how easy do you make it that you're really not learning anything, or how involved is it, so that people they're using it as a tool, not a learning experience. And maybe there's a fine line between corporate trying to make it so easy and customer centric that you turn it on and it turns on, it's easy, and everybody's happy from a customer perspective who's trying to line up a new project. But from a learning perspective, you're short-circuiting a lot of that. Well, how did you get there? And why is that important? And perhaps the community isn't always aligned there to explain the journey of how you press the button, and 5 minutes later, voila, you have all this stuff at your fingertips. It's kind of like your iPhone now, where 5-year-olds pick it up and they're like, yeah, okay, I got it. I'm turning on video, and they figured it out because it's easy, but they have no idea, how or why it works. So with that being said, Shawn, maybe you can kick us off on the next subject, which is, learning self-directed activity is great, but at some point there's probably some either micro or mega trends that are coming down the pike that a broader audience is going to have to start tackling and integrating into their learning, both professionally and certainly for makerspaces. Shawn, what do you see coming down the pike in the next couple of years that yourself are trying to get your head around to put into your work, and what are you trying to learn in those areas to really accentuate some of your thoughts about Make?
So my big thing recently has been machine learning, and I'm sure everybody's heard it's kind of the new hype. It's the, like, I joke it's the new IoT. You know, what is it? 7 years ago, everything was IoT, and then like we're finally starting to realize what the limitations of IoT are. I see personally machine learning kind of being the new DSP. If you think back to like the 80s, not that I was around to witness this, but DSP was this big thing, and these companies came out and they offered specialized DSP chips, and it kind of changed what the embedded world did. And I think machine learning is going to do the same thing for embedded, and that's my world. I think, you know, broader for electrical engineering, things like batteries and energy storage. You know, that's, you know, you get into like chemicals. Excuse me, you get into like chemical engineering at that point, but safe energy storage, so that we're not driving around on lithium-ion bombs is, I think, a huge thing. So that's going to be very important, you know, energy efficiency, smart grids, all these things. But for me personally, it's been machine learning. Specifically, how do I apply that to embedded? Because I love the idea of, we now have these small devices that, you know, either can learn, whether, or more appropriately, they're probably performing inference. And what that does is we're no longer having to pipe a ton of data across the internet for an IoT device. And that device is smart enough to make some basic decisions. Like, do I see a person in the camera? And then all I have to do is turn on and off the lights, right? This is better than those IR sensors. Or maybe there's somebody at my door and I can positively identify that there's a person, rather than streaming a video, you know, a full video stream across the internet that you have to perform inference on a remote server. I think there's a lot of energy saving there. And then things like predictive maintenance is huge. Being able to identify when machines are going to break and being able to maintain them or fix them before they do. That's a big research area. And I think that has a lot of potential applications in TinyML or embedded machine learning, because now we can have little devices on $1 million machines that go, hey, something's wrong. You know, I hear, or I feel, or something looks wrong. Come take care of this.
So Katie, just moving in another spectrum for you at school, you with Project in a Box, your experiences to date, and you're looking at your curriculum, you're looking at your outside activities. What do you see as a student that's coming down the pike that maybe you're looking at to grow into, that you know will be important, but you haven't quite hit it yet at school?
At school, I guess some of the things, yeah, I would say machine learning is also another one that there's a lot of, I guess, hype around at school that I haven't personally taken a lot of courses on yet, but there's definitely a lot of opportunities there that I just haven't gotten to yet, I think.
So maybe your Project in a Box, if you want to elaborate on your Project in a Box, where a future technology or a future direction of technology, what would affect it, and how would you improve it or watch out for it coming up? What about the Project in a Box that could use or map to a future like machine learning or energy or, you know, artificial intelligence, sensor networks, you know, just something that's progressing at a rapid pace?
Yeah, I think so. In Project in a Box, we develop a lot of project kits that can be used to like teach different concepts. And yeah, we currently don't have, I think we might have like one basic machine learning project, but like, I think one thing that we hope to expand in the future is like looking at other tools that are out there that we could use in our kits, that we can, I guess, teach other students. I'm not exactly sure what those tools would be exactly yet. That's something I'm definitely open to exploring more. Yeah.
So Bob, maybe going over to you, what, you know, given in corporate, you get exposed to obviously a lot more roadmaps, you know, kind of where's R&D going and things like that. But clearly from within the company, people in their organizations and silos must be whether it's the applications team or the design team, obviously have to continue to learn and pick up skills. And they have to be pretty forward thinking, because the last time I checked, putting a chip to market takes 18 months if you're good, 2 years if you're okay. And sometimes if you're doing real R&D, it takes 3 or 4. What are some areas that you see that are going to kind of cross section that, given that you're in semi?
Yeah. So tailing on to the machine learning hype, yeah, absolutely. But what's happening is, you see all this machine learning stuff, and yes, we can draw boxes around a cow and identify, that cow that's surrounded by that green box at 99% probability that it's a cow. But it's the implementation of those inference models in those tiny models running on those edge nodes. And a big push for us right now is what's called functional safety. And that is, you have this model, but the model was built through the inference engines that had this absolute trust in the actuators and the sensor platforms and whatever. And it's really hard to, adapt to every, data set anomaly that happens, right? For example, a very popular electric vehicle manufacturer out there has a penchant, their products have a penchant for running into emergency vehicles on the side of the road, to the point where now they're being investigated by a government agency on why a $25 million or 25 million transistor machine learning processor can't distinguish between a stop, an empty road and a stop fire truck. So things like we're dealing with, functional safety and making sure that implementation of a machine learning model, that there's a chain of trust all the way down. Like if you have a short circuit or there's just a hard limit, this EV wheel motor cannot push more than this many amps, and you shouldn't have to go through an inference model to shut that motor off, right? So it's the proper implementation of all this wonderful machine learning models that we're dealing with now. Plus, as Shawn mentioned, the IoT turned into IIoT, which is the Industrial Internet of Things. Yeah, I can count the number of socks in my sock drawer and punch it up to Amazon, but do I really need to do that? Because IoT tends to be the worst case scenario for internet routing. Billions of small packets, no static routes and routers anymore. So stuff like that.
So Kevin, given you're sitting on top of not only a pretty substantial infrastructure, I'm sure it's funded well, even though you'll probably say it's not. And from your vantage point, what technology areas are you trying to drive in the Hive? That's not too far away, so that people don't shy away and think it's not for them, but that you see coming that either yourself have to get on top of, or bringing that into the institution that you think would, be a good thing to have people start thinking about in terms of technology adoption.
Right. So as previously mentioned, before I was the director at this facility, I worked 8 years in the curriculum doing capstone and hands-on experiments. And I'm sure, with that comes, you see all these trends and all these technologies that come out, and technology is very quick. So I realized it's hard for me to keep up with everything that's new or relevant. So what I rely on is really our students. Instead of me trying to dictate, what we should be learning in the facility, I'm paying attention to what they're learning now in classes. I'm looking at our work channels, seeing what the students want to see in the space and trying to keep up with it. Because, it'd be one thing for me, because when I was in school, we were using, PIC controllers and all that. And now when I was doing capstone, it was Arduinos, and now we're doing other stuff now. And so I constantly try to pay attention to what kind of conversation the students are having. There's a very robust inventory and operations committee at our center to make sure that we don't fall behind in the technological advances. So if we need to buy more computing powers, we're buying more VR headsets, more equipment to keep up with these trends or the needs of technology, we will. And so that's how we kind of deal with it space.
Right. I know we have about 8 minutes left, no, seven minutes left, and to hit this home with the panel, I'd like to try to ask each of you to tell a personal story of enlightenment, if you will, over the last year of something that you can translate to the audience about, that you took this topic and you acted upon it yourself. About how did you learn something new? How did you keep growing, whether it's COVID related or not? And maybe Kevin, since you're on my screen and staring at me, you want to talk about something that you've done personally in the last 12 to 18 months that you took it upon yourself to go learn and felt like you had to grow to continue to add value to your role there at Georgia Tech.
Yeah, sure. Let's talk about just 3 weeks ago. I finally learned how to use an email. It's basically has your digital readouts, and it's a machinist tool. And this is part of what, listening to my students, or serving what they want in the space resulted in. They asked me for about 2 years, can we have an email? I gave them a really, really bad meal. And I said, if you guys can make something amazing out of this, a couple of things, I will purchase y'all an expensive email. And they did. So I worked on about a year to actually procure this mill. And we finally got into space about a month ago. And so I think it's important for someone like me, instead of just being an administrator, I need to be in the field learning things myself. So I was actually taught by a PhD candidate who actually has experience in email, and we're working together to develop a teaching course how to use it. But it was an experience. I'm 34 years old, still learning, all the different types of machines. And as an electrical engineering background, I don't have that kind of mechanical background, but I am open to receiving it because I realize, engineering is diverse. And if I understand even the most basic of machining or whatnot, it will make me a better designer, a better participant in the maker culture. And so I think it's important for me to actually have done that with our students.
Awesome. Shawn, maybe kicking it over to you. Obviously, you're always reinventing yourself, if you will, trying to put out the next great thing. Can you describe something that you took upon yourself in the last 12 to 18 months that you felt like you had to go learn and did it on your own?
Sure. That's actually, but first of all, the bow tie hasn't changed in a long time. Maybe I'll reinvent myself one of these days and maybe it's a necktie. I don't know. I'll bring back the bolo. There we go. I think for learning, that's actually essentially my job, is to learn new things and translate it into something that's a little more approachable for people in video format. So I try to stay abreast of a number of things. The big one for me in the last 18 months has been machine learning. And it was a combination of things for me that included taking Andrew Ng's class on Coursera, which was phenomenal. And then there was a few books that I had that I'm currently either worked through or currently work through, like the hands-on machine learning with Python, TensorFlow, and something big, thick, 1,000-page book. Great. I'm almost halfway through it. It's slow. That's been a good one. And for me, interestingly enough, there's this balance. And I think, this makes me think back to when I was a student and how I was learning, and where we can get into some individualized learning techniques, because I know that's probably a big thing for some professors, for some, even high school teachers. For me, I actually do pretty poorly with a book. I struggle with reading. I don't know if there's actually a potential learning disability that I might have, but concentrating on blocks of text is horrible for me. I do much better with presented format, like taking a course, watching videos, listening to somebody do it, and then doing the hands-on portion of actually, making the thing, construct this neural network. And we used MATLAB/Octave, and that helped. And then when I'm going through the books, the only way I can stay focused is I either have it as a PDF or I open it and I copy down exactly what they're doing, make it work, and make little changes. Even if I don't fully understand the concepts behind the lines of code, for me, it's just getting that practice of, this is what's going on. And then I create these building blocks that I can go back to and I have this project idea in mind, or this is how I want to teach it. I have this now storehouse that I wrote down myself that I can bring in these blocks and go, let me explain, and I'll, learn, I'll go research what these individual blocks do. and explain it in my videos. So now I have a better understanding of what's going on by creating something from that that's my own. And that's part of that maker mentality. But for me, it's my job. I have to present that information now. And then recently I've been doing the exact same thing with FPGAs. I also went to Twitter and said, hey, how do you all, what do you recommend for learning FPGAs? And oh man, did that create a holy war between Verilog and VHDL. I won't even go into that. I'm sure any of you have taught that, have run into those.
Depends where you are in the world, I think, but.
Yeah, well, yeah, exactly. Are you DoD or university, or are you, another company? But for me, I found this great open source tool suite that's Yosis. There's this thing called Appio that's built on top of it. And that makes the process of getting my design to an FPGA so easy that I can focus on the actual digital design and writing Verilog, because that's all it supports right now, for my design. I don't have to fight with a tool set any longer. So like finding these tools, finding what other people are interested in has been super useful for my learning because it makes that process much easier.
Awesome. So Katie, just for you, I know Project in a Box is something that you champion and that you're proud of. Just describe maybe something, obviously being a junior, something in the last 12 months that you took upon yourself outside of Project in a Box, maybe, that you had to tackle and grow on your own outside of curriculum.
I see. Yeah, I think the main thing I've been focusing on recently probably has been Project in a Box, mostly because I think I've been learning a lot about like trying to become like a better leader. And I know we've been talking a lot about like technical skills during this panel, but I think part of another aspect is like learning soft skills and trying to like learn about collaborating with other people and working on just building this org. And I think there's a lot of other things that I've learned about through leading, like there's a lot of logistical things like budgeting and like logistic events, hosting events and all that I've been learning about recently too. So I think it's also been a balance between developing my technical skills as well as soft skills as well. So yeah, that's like the main thing for me recently.
Great. Well, Bob, you're gonna close this out for us in just a minute or two before we have to transition. Just something that you did in the last 12 months that you felt like you can pat yourself on the back and say, yeah, I really tackled that on my own.
Yeah, so there's two things. One, not only did we have COVID, rushing across the planet, but here in California, we had all those nasty bushfires and the air quality. So in my previous life, I did a lot of upper atmospheric telemetry measuring. So that's kind of, a comfortable space for me. But I managed to spend a lot more time on local, like particulate, like ppm 2.5 or whatever, and learning about that and putting together some systems that so I had to learn more about the systems to measure air quality at ground level, and also was trying to get my head around, and I use the term standards are wonderful, everybody should use them, because like there's going to go Purple Air that really set up this really cool network, but their ppm numbers were running differently than some of the official, government websites. And I was curious as to why that was happening. So I did a deep dive into that type of thing. And then I was also fortunate enough to meet a wonderful young man who I'm mentoring now as well. And he introduced me to the world of high-powered model rockets. So I've been doing a lot of stuff on taking some of my telemetry designs and adapting them to like 15G, 10,000 foot type of launch cycles and all the interesting physics and tribal knowledge around model rocketry right now. So it's been a kind of a fun diversion.
Maybe you can call Captain Kirk. He just came back from space.
Yes, yeah. So that's I'm almost not quite a Captain Kirk, but yeah, because I saw launch and then instinctively it was a big rocket. It went pretty high, but it flew into the wind, and that intuitively that doesn't make sense. But then as as this young man pointed out, no, it's center of pressure versus center of gravity. I went, oh, now that makes complete sense. And I went,
So you're learning.
I'm learning. And I was, again, I try and learn something, maybe not new every day, but certainly, I was intrigued that why, as an engineer with over 30 years experience, why didn't that intuitively come to me? But as soon as he explained it, it did,
Yeah.
So it was just,
well, I can tell you, I've learned that my son goes to Auburn, and I've learned that they're not going to be a national champion this year. And so, yeah, this has been a great panel. Really appreciate everybody's time. For those in the audience, I think we have to wrap it up because we have to transition, but certainly anybody who wants to reach out to Shawn or to Bob, to Kevin or to Katie offline to continue the conversation on something that you heard or something that inspired you, hopefully everybody can do that. But in the end, as the topic concludes, it's really about how do we continue the learning process, both from a university perspective, from a professional perspective, to keep us moving forward in ECE. So thanks for the panelists. And I think that's a wrap.
Okay, it looks like everybody is back. Thank you all again for a wonderful day of programming. And I guess at this time we have a few minutes left, and I'd like to pass it off to YC. And thank you, YC, once again for your leadership in this program. It was an excellent 2 days worth of content, and we look forward to posting the materials on the website. But if you have some closing thoughts, we'd love to hear from you.
Perfect. So you know what? I originally conceived of this, the overall theme for this October ECETA Summit out of curiosity, because I wanted to know what academia is doing. I wanted to know what people are thinking out in the industry, and specifically, people from startups. That's why I invited 2 startup founders to this summit, and it's been a learning process for me as well, and I'm glad to see there is a concerted effort out in academia to better prepare the students for the industry, and it's an ongoing process. And also I'm glad to see that the industry is now beginning to realize, okay, there are certain things that we're looking for in a new college grad now that may not be apparent 10 years ago. And so it's it's quite amazing to hear viewpoints from both sides, and I really want to thank all the panelists, both from academia and industry, and everyone for attending and all the great questions you have. So this is great, and DigiKey will have another summit not summit, another event coming up either right before the holiday break this year in December or early in January. Stay tuned, and that will be focusing on products and services that can help your student with capstone projects, which is probably the hottest thing that's going on in the senior year student population right now. So stay tuned, and thank you very much to ECETA as well.
Great. Thank you all. Have a great day.
Thank you.
Thank you.